Okay, year 11. In this video, we're going to look at angles of elevation and depression. Now, the angle between the horizontal and the angle between the line of sight is called the angle of elevation. So here's your line of sight, here's your horizontal, and this is the angle of elevation. The angle of depression is the angle between the horizontal and the line of sight. So let's just say you're looking down from a height. The angle between your line of sight and the horizontal is called the angle of depression. Now, with the angle of depression, there is a property that you have to know from geometry, and it's to do with parallel lines. So this line here is parallel to this line here, right? And that means this angle here, theta, is equal to this angle here, due to alternate angles on parallel lines being equal. This angle is also theta. So once you know this angle, you straight away know that this angle is the same. Okay, let's have a look at an example. The angle of elevation of a tree from a point 50 meters from its base is 38 degrees 14 minutes. Find the height of the tree. So let's draw the tree. There's my tree. I'm essentially just going to draw a right angle triangle to start with. Okay, now the angle of elevation is 38 degrees 14 minutes. So this is my angle of elevation, 38 degrees 14 minutes. And let's just tidy it out, that 8 up here. So 38 degrees, 14 minutes. 50 meters is the distance from the base. We've got to find the height of the tree. So here's the H for height of the tree. Now, in that diagram we've just drawn, the opposite side is here. The hypotenuse is here. The adjacent side is here. The two sides we're working with are the opposite side and the adjacent side, which is tan. So you can write down tan theta equals opposite divided by the adjacent side. So tan of 38 degrees 14 minutes is equal to H over 50. And then we're going to multiply both sides by 50. It cancels the 50s, and then you get H on this side, and you're going to work out 50 times tan 38 equals, it'll be 39 meters to the nearest meter. Okay, so that's it. So we'll look at question 2 now. So the angle of depression from the top of a 20 millimeter building. Okay, so let's draw a right angle triangle again. In all these diagrams, we need a right angle triangle. Okay, so the vertical height is 20 meters for the building. And now it says the angle of depression. The angle of depression is always measured to the horizontal line. Here is our line of sight. So the angle of depression is the angle when looking down. So that's 61 degrees, 39 minutes. How far is the boy from the building? So let's call this distance here. The boy is here. So you've got to work out X. Now, let's have a look at labeling the sides. So you're going to have this angle here is 61 degrees, 39 minutes. Now that means this angle here is also the same. 61 degrees, 39 minutes. Okay, so the opposite side to that orange angle is here. The adjacent side is here. Those are the two sides we're working with, so it's tan. So tan theta equals opposite divided by adjacent. Tan 61 degrees, 39 minutes equals 20 on x. So x is equal to 20 on tan 61 degrees, 39 minutes, which equals 20 divided by tan 61 degrees, 39 minutes, equals, you're going to get 10.8 to 1 decimal place, so 10.8 meters. Okay, so that's x. All right, so that is it. I may as well look at exact trigonometric ratios as well. Okay, so we've also looked at exact ratios, and if you look at this right angle triangle, it's isosceles, and so we've got 1, 1, root 2. So in any isosceles triangle, if you think about it, which is right angled, so if you drew any isosceles triangle which is right angled, so this side equal to this side, these two sides, these two angles have to be 45 degrees each. Okay, so if this length is 1, that means this length is 1, and by Pythagoras that is root 2. From here we can see that sine 45 is exactly 1 over root 2, cos 45 is exactly 1 over root 2. Now that's not true, is it? Tan 45 is equal to 1 over 1, which is equal to 1. Okay, now what about an equilateral triangle? Let's say we've got an equilateral triangle with sides. There's an equilateral triangle. Now we know with an equilateral triangle, 3 sides are equal, and the 3 angles are 60 degrees. Let's just say the sides are 2, 2, and 2. That just makes it a little bit easier. So now, if they're 2, 2, and 2, and we draw a line right down the middle of the triangle, that means we have this to be 1 and this to be 1 as well. So 1 is half the length of the base. And if you look at the triangle over here, how do we get that root 3? Well, because this is a right angle here, we can use Pythagoras to work this out to be root 3. So then we can get some more exact ratios, can't we? We can work out that sine 60 is root 3 on 2, cos 60 is a half, tan 60 is root 3, sine 30 is a half, cos 30 is root 3 on 2, and tan 30 is 1 over root 3, all from this one triangle over here, okay? So then we can use those exact ratios. Now let's, I'll just change that question. Find the exact value of 1 over cos 45 degrees. That's better. Okay, now 1 over cos 45 is just 1 over 1 on root 2, which is equal to 1 multiplied by root 2 over 1, which is equal to root 2. Okay, that's the first one. Now, what about this one? A boat ramp is to be made with an angle of 30 degrees and base length of 5 meters. So if you look at our right angle triangle as the model, okay, there's our ramp. So we want 30 degrees in here. Yep. Base length is 5 meters. What is the exact length of the surface of the ramp? Let's call that x. Okay, now, here's my angle. This is the adjacent side. This is a hypotenuse. So I'm working with cosine. So cosine of theta is adjacent over hypotenuse. And that allows me to then say that cosine of 30 degrees is equal to the adjacent side, 5 on x. So swapping those over, I get x equals 5 on cosine of 30. Now, what's the exact value of cosine of 30? Well, think back to your triangle on the previous page. This is 60 and 30. This was 2, 1, and root 3. You can see that cosine of 30 is root 3 on 2. So this is 5 over root 3 on 2. And we know that when we're dividing fractions, we flip and divide. So that'll be 5 multiplied by 2 on root 3, which is 10 on root 3. Okay, so it's not quite the same answer. That'd be good enough. I'll put meters next to that, but you can also rationalise the denominator if you wanted to. So you could also go 10 on root 3 multiplied by root 3 over root 3, and that gives you 10 root 3 on 3 meters. So that's another way. But this here answer is fine, unless the question says rationalise the denominator. Okay, and that is it.